Assalamu alaikum wa rahmatullahi wa barakatuh. You are welcome back to the online class. Today we'll be looking at indicators. What are indicators? Indicators are weak organic acid or bases that change color according to pH of that solution. We can equally say indicators are weak organic acid or bases that produce different colors according to the pH of that solution. Now, types of indicators. We have different types of indicators. We have different types of indicators. We have litmus paper is an indicator. Phenolphthalein is an indicator. Methyl orange, methyl red. They are all examples of indicators, etc. The next thing we are going to look at is common indicators and their pH range. Common indicators and their pH range. We are going to look at the different color each indicator produces, whether they are in acid, base, or neutral solution. Let's look at litmus paper. Litmus paper in an acid used to be red. In base, it used to be blue, while if it is neutral solution, it is purple in color. Now, methyl orange. Methyl orange in an acid used to be pink. In base, it is yellow, while in neutral solution is orange in color. Phenolphthalein indicator. Phenolphthalein indicator in an acid used to be colorless. In base, it used to be purple in color, and then in neutral solution, it also used to be colorless. Methyl orange indicator. And methyl red. Methyl red in an acid used to be pink. In base, it used to be yellow, while in neutral solution, it used to be orange in color. So these are the colors of these different indicators in an acid or in base. Now, the next one we are going to look at is the universal indicator. What are universal indicators? Universal indicators are mixtures of dye. They are mixtures of dye that gradually changes color. They gradually change color over a pH range. That means as their pH is changing, they also change color. We say they are mixtures of dye. Yes, because they contain different indicators like phenolphthalein, methyl orange, and then methyl red. Now, that is that about indicators. Now, indicators also, they changes color between the pH of 2 and then 13. They change color between the pH of 2 and then 13. That is that on the universal indicator. Another thing we are going to look at is properties of indicators. Properties of indicator. One of the properties of indicator is that they are cheap. That is one of the properties. They are also non-toxic. That is number 2. They are non-toxic. Number 3 is that they are easily detectable. That means you can detect them because of their color change. It is easily detectable. And then another one is that they produce a what? Sharp color change points. They produce sharp color change points. That's because they have different colors. They have different colors. So they produce these colors according to the pH of the solution. Now, the next thing we are going to look at is choice of indicator for different titrations. Choice of indicator for different titration. Now we are going to look at four different types of titration and the suitable indicator that we can use for that types of titration. Number 1, titration of strong acid and then strong base. If we are titrating strong acid and against strong base, we can use any indicator. Yes, I said any. But any is not a right answer. We have to be specific in what we are saying. If I say any, that means we can use any indicator, like phenolphthalein indicator is suitable, methyl orange is suitable indicator. So we can use them. Now, number 2, the titration of strong acid versus weak base. Strong acid versus weak base. The indicator we can use is methyl orange, because it is methyl orange that will be able to detect between that pH range, strong acid versus weak base. Methyl orange will detect any change there. Then another one is weak acid as against strong base. The suitable indicator for that is phenolphthalein indicator. Phenolphthalein indicator. That is the indicator we can use for that. And then the last one is weak acid versus weak base. Weak acid versus weak base, there is no any suitable indicator. That means there is no suitable indicator that we can use for that type of reaction. So that is that on that. Now let's look at this titration curve, the one I placed on the board. If we look at number 1, I said strong acid versus strong base. At the beginning, when the base is added to it, we see that there is a slow increase at first, increase in the pH, and then later, gradually, it becomes rapid, and then we have an end point, and then later it goes slowly like that. Now, the indicator that can dictate, or we can say any indicator that can dictate the pH between 3 and 11 is suitable for this type of reaction. Any indicator that can dictate pH, that can dictate between 3 and then 11 is suitable or can be used. Now, if we look at number 2, the strong acid versus weak base, the same thing. It keeps on slowly increasing and then rapidly, and then when it gets to the end point, it becomes slow again. The suitable indicator that we can use for this is the one that can dictate a change between 3 and 8. Between 3 and 8. Any indicator that can dictate a change between 3 and 8 is suitable. Then we have weak acid versus strong base, which is the third one. The same process, like that. And the indicator that is suitable for this type of reaction or for this type of titration is that one that can detect change between 6 and 11. Between 6 and 11. I said this one, 3 and then 11. This one, 3 and then 8. Why this one is between 6 and 11. So the indicator that can detect change between these can be used. Now the last one, weak acid versus weak base. Like we said, there is no any suitable indicator for this particular reaction. There is no any suitable indicator for this particular titration. Now, the next thing that we are going to look at, that is all about indicator. The next one that we are going to look at is buffer solution. Buffer solution. What are buffer solutions? Buffer solution, they are the solution that can resist change on the addition of small amounts of acid or an alkali. Small amounts of acid or an alkali. That is buffer solution. Now, types of buffer solution. Types of buffer solution. Types of buffer solution. There are two types of buffer solution. One, the alkaline buffer solution, and then number two, we have acid buffer. We have acid buffer. One, the alkaline solution, they are solutions that contain weak acid and their salts. Alkaline buffer, they are the solutions that contain weak base and their salts. Weak base, for example, ammonium hydroxide and ammonium chloride. That is an example of alkaline buffer. Now, acid buffer. Acid buffer, on the other hand, is a solution that contains a weak acid. It contains a weak acid and its salt. For example, you can hydrogen triazocarbonate 4, hydrogen triazosulfate 4, and its salt. It may be sodium triazosulfate 4 or potassium triazosulfate 4 in their solution of their acid, that is weak acid. That is another the example of acid buffer. Now, how do they resist this pH? We say buffer solutions are those solutions that resist pH when small amounts of acid or base is added to it. That means there will be no change in their pH. Now, how do they resist that? Let's take an example of acid buffer that contains ethanoic acid, which is a weak acid, and then sodium or potassium ethanoate. Let me take potassium ethanoate. It is salt. Now, when this one ionizes in water, okay, let me use this. When it ionizes in water, it's going to produce ethanoic ion, and then sodium ion. Now, any addition of any acid, small amount of acid inside, this ethanoic ion is going to absorb the acid, and then it will reduce the pH. That is how they resist pH. That is, any hydrogen ion, any acid that is added, the hydrogen ion that is produced by this acid in solution will not increase the pH, because this ethanoic ion will absorb the hydrogen ion, forming ethanoic acid back. Now, the alkaline buffer also, where we have ammonium hydroxide and then ammonium hydroxide and ammonium chloride. The same thing. When this ionizes in water, it produces ammonium ion and chlorine ion. Now, any small amount of base that is added to this solution, this ammonium ion will absorb it, forming ammonium hydroxide. So the hydroxide ion produced by maybe either sodium, you added sodium hydroxide, or any of the base that you added, the hydroxide ion produced by the base you added will not have any effect, because the hydroxide ion produced will be attracted by this ammonium ion, forming ammonium hydroxide back. So that is how they resist pH. Now, that is that. Now, we have seen types of buffer solution. Now, let's look at the uses of buffer solution. One of the uses of buffer solution is that they are used in the industrial processing of food and drinks. We use it when we are producing food and drink. Another one is that they are used in the biological processes, medical processes, biochemistry processes, and then in chemical processes to maintain constant pH. We use it to maintain constant pH during biological process, chemical process, medical process, and biochemical processes. So these are the two uses of buffer solution. These are the two uses of buffer solution, and this is where we are going to stop our class for today. Please, the notes will be attached to this video. Take a look at the notes, understand it, it is very explanatory, go through it, and then assignments will also be attached. Please make sure you do your assignments. This is where we are going to call it off for today. We will meet in the episode or in another episode of the online class. Please stay home, stay safe. Assalamu alaikum wa rahmatullahi wa barakatuh.